Hey there, chemistry students. This is Mr. Caldwell. Hoping that you guys can see this screen, and just wanted to show you a couple of interesting little things here. Um, the main point is we're talking about solids and liquids and gases, and as I scroll through these notes, the assignment that you have that's out there today is on phase diagrams. So there's some interesting information here on phase diagrams, but I think that it's all been reasonably addressed in some of the previous videos. So I'm not going to spend a ton of time here. What I did want to do with this video is just touch on a couple of the things that are highlighted in this part of the notes. And I think that we know, excuse me, much of the information here about solids and liquids and gases in terms of their organization. We started the year out in chemistry talking about how solids, the particles, they are packed in pretty close. They're moving, but they're not moving a ton. And as you heat them up, then they become a little bit more disorganized. The particles are now moving around. They're colliding with each other. They don't hold their shape as well, which is why liquids pour out onto a tabletop and they just kind of go all over the place. And then gases, as you continue to heat those liquid molecules or atoms, whatever it is, they are now going with such energy that they are just flying all over the place and are very disorganized. A couple of words here that you may not have encountered. Solids can be either amorphous or crystalline. And amorphous solids are anything that's going to have no regular repeating pattern. And there's lots of examples out there. The one that I've given you here is glass. It's silicon dioxide, but they're just very willy-nilly, randomly associated with each other. There's no repeating, organized pattern to that solid. So that's called an amorphous solid. And I think we're more familiar with sort of an ionic compound, a crystalline structure. These guys are going to have a definite pattern to the arrangement of the molecules or the atoms in this type of a solid. And so just wanted you to be aware of those two words. You've got three different types of, three different types of crystalline solid pictured there. All right, but now let's look at liquids real quick because I just want to show you a kind of cool little thing. I'll have to pause the video in a second. Um, Liquids exhibit a couple of cool properties here, and one of them is called surface tension. And if you have ever been out in the out in the woods, out in the country, and you look at a surface of a lake or a stream bed, you might see what I call water striders. They're these little spider-like looking insects, and they literally sit right up on top of the water. And the reason that they can do that is because water molecules hold on to each other pretty tightly. And in doing so, those little water striders are so light, and they have a little pad on the end of their little insect legs. They kind of flit about on the surface of the water because of this thing called surface tension. And surface tension it really is kind of cool. It makes interesting things happen. And so water molecules hold on to each other. And I'm going to pause the video and show you a little bit of a cool demonstration. Okay, so what I've got here is just looks like a penny. It's actually a Euro 2-cent coin. And I've got it falling out of my hands. I've got it up on this just so that it's kind of a little bit elevated so you can see. And I'm hopeful that I've got this close enough to the camera that you guys can see. I don't have a dropper, but what I am gonna do is I'm just gonna kind of squeeze out some water. If I have enough water, I think I gotta pause this and get some more water in my cloth here. All right, let's hope that I've got enough water on here. So now what I'm gonna do is I'm gonna just try and squeeze out some drops. Now, I know that the camera is not great here, but hopefully you guys can make out that, and it just dribbled off. I'll dry this into it one more time. So surface tension is basically a property of liquids, whereby the liquid particles themselves because of intermolecular forces. Remember, we talked about those right there before spring break. Intermolecular forces in between the liquid particles hold on to their neighboring liquid particles and allow liquids to kind of hold on to each other more tightly than you'd expect. And so if I kind of dribble some more water onto here, this is a little tricky, not easy to do without an actual dropper. But you can see sort of this muffin top, this big blurpy bubble of water forming on top of the penny. And if you look at it from the side, it almost looks like a hamburger bun getting ready to like just slide off of the, and so that's a pretty big, thick layer of water. And the reason that that's there is because of surface tension. Now, once it's broken, the water all just goes away. So let me put this away and dry off. Okay, so kind of a cool little demonstration there. A little bit tricky with the limited camera that I have. So last little thing here, a couple other words I wanted to share with you. Capillary action, all right? If you have a really, really thin glass tube, super tiny diameter, what you can actually do is you can just put that little glass tube, and if you type in YouTube a capillary action, you'll find all kinds of videos with it. So there's two types of forces. There's adhesive and cohesive forces. If you think about what adhesive tape does, adhesive tape adhesion is connection, an attachment between one material and another material. The tape usually attaches to a different material. So when you have an adhesive force, what you're looking at is the attraction between one material and a different material. So with what's called a capillary tube, water molecules are actually attached to and attracted to the glass walls of the tube. And so those adhesive forces are actually a little bit strong. And if you're not having to move very much water, which would be the case in a very small, narrow tube, those adhesive forces are actually stronger than what we call the cohesive forces. Now, cohesive forces were basically demonstrated in that little demonstration I showed you with the water on the penny. Cohesion, if you have a cohesive group, they are bound to one another. They're tightly knit. And so if you have cohesion, you have water molecules holding on to their neighboring water molecules. All right. And so that's an example of cohesion. And in capillary action, the adhesive forces, right, the attraction between the water molecules and the walls of the glass tube are stronger than the cohesive forces, which are the forces between the water molecules themselves. And what you'll see in capillary action is that water will actually just rise, seemingly as if by magic, right up the walls of the tube because of that adhesion being stronger than cohesion. It's also why when you look at a graduated cylinder, here are the walls of the cylinder, all right? And the water inside the graduated cylinder always makes sort of a curvy shape. And the reason for that uptick towards the walls is because of adhesion. All right, the adhesive forces between the water molecules and the walls of the graduated cylinder are stronger than the cohesive forces holding the water molecules to each other. And then this last word, viscosity. Everyone has experienced viscosity if they've ever tried to pour maple syrup on a cold winter day. Love maple syrup. But if you turn that thing upside down, that maple syrup, those maple syrup molecules hold on to each other very tightly. They don't want to let go of each other. So even though gravity is trying to pull them down out of the container, there's a high amount of cohesion and those molecules just stick to each other. So it's a resistance for a liquid to flow. That's what viscosity is. Typically, you buy motor oil for your car depending on the viscosity. If you need to have sort of uh, thick motor oil, that would be a high viscosity. If you need a thin motor oil that's going to be able to flow very easily across the metal parts that you're lubricating, you'd want a low viscosity. So I just wanted to kind of run through these words rather than just have you sit there and read them. Hopefully this helps a little bit. If it doesn't, then you know what? You got to see me for a couple minutes and listen to me yabber about some cool things. I hope everybody is well, and I will be seeing you guys online again soon. Take care. Bye-bye.